Welcome to Ask and Learn.
We are given a differential equation and a point in the plane, and we are asked to find the slope field of this equation and the solution which contains this point. Our differential equation is y prime equals y minus 2x, and the point in the plane is 1, 0. To draw the slope field, we'll draw part of the plane, and I'll make the measurements on the x and y axes different for clarity. If we set the slope y prime equal to c, for some c in real numbers, it follows that this is equal to y minus 2x, and therefore that y is equal to 2x plus c. This is the equation of a line with slope 2 that has y-intercept 0, c. And for all points on this line, we have that y prime at that point is going to be c. So, for example, if we take c to be 0, find all the points which have y prime at that point equal to 0. These are all the points which lie on the line y equals 2x. In particular, this includes the origin, includes the point 1, 2, and the point 2, 4, and all the points in between on the line. If we take c to be plus 1, so we're finding all the points for which y prime at that point is 1, then these are all the points which lie on the line y equals 2x plus 1. This includes the point 0, 1. We'll have a slope of 1. So we go up 1 and then over 1. It's a little bit tricky to see in the picture, but this is actually somewhat flatter than you'd expect. We also have an x-intercept of x equals negative 1/2. And all the other points in this line have the same slope. c is equal to positive 2, but we have a slope of 2. These are all the points that line to line. Y equals 2x plus 2. So in particular, the point 0, 2 lies in this line. And this has slope 2. So we go up to 4 and over to 1. Really hard to see. We have a slope a little steeper. We also have an x-intercept of x equals negative 1. Again, it's a little bit steeper than the lines beneath it. And of course, all these other points in the line are going to have the same slope. And so we can see that as we get further and further away from the line y equals 2x plus 1, these slopes are going to get steeper and steeper. So it'll look something like this. Now, let's say if c is going to be less than 0, we see that again we have these parallel lines with slope 2, and as we go further and further away from the line y equals 2x plus 1, the slopes on these lines are going to be more and more negative. So it will look something like this. And again, this is just a rough approximation of the actual slope field. But it gives a good idea of what the curves might look like. So we have representation of our slope field here. And we're asked to find the solution, which has a point 1, 0. So I'll draw the solution in red. Now, since it has the point 1, 0, we'll locate this on our graph. 1, 0. And we'll follow the blue line segments, stay as tangent as possible to them with our curve. So we'll see that this quickly as x goes to positive infinity, this goes towards negative infinity. And we see that as x goes to negative infinity, we start by going up a little bit, and as we reach the line y is equal to 2x plus 1, start to level out, and then decline again as we follow that line as an asymptote.